Okay, you're performing a diagnostic on a drivability issue, maybe a misfire code, and you suspect there's a problem with the engine mechanically. Suspect a loss of compression or low compression in one or more of the cylinders. Traditionally, methods would require you to perform a manual compression check on all the cylinders, and that can be time-consuming and problematic on some transverse designs, requiring plenum removal or other component removal in order to access that rear bank of cylinders. So I want to show you a couple of different ways that you can do that same type of test to get an idea of the engine's mechanical condition before you go through that much trouble. It's all based on what's called relative compression, where we're using a method that compares each cylinder together with the weak one, of course, standing out as the low performing one. In this case, we're going to use starter current on this first one to determine the relative health of the engine. Good cylinders are going to require a certain amount of push from the starter to turn through. Of course, a weaker cylinder less, and that will show up in the amount of current that the starter draws to turn that cylinder through. Now, that's using a lab scope and a high amp clamp to get that information. I already have the scope hooked up, ready to trigger, and now let's go ahead and crank the engine over. Remember, when you're doing a relative compression test or even a traditional compression test, you want to avoid washing the cylinders down with fuel while it's not starting. Of course, that's the first thing. Disable the system so the vehicle will not start. And the easiest way to do that is disable the fuel system, either by disconnecting the injectors, disconnecting the fuel pump fuse, fuel pump relay, otherwise preventing the engine from starting and washing down the cylinders. You certainly don't want to create a problem that wasn't there before you started. Now that I have the pattern on my lab scope, we can go ahead and take a look, see if we can spot any weak cylinders.
Let's start with a normal pattern. The blue trace is measured starter current taken with the high amp clamp attached to one of the battery cables. It doesn't matter which one, since current flow is the same anywhere in the circuit. Once the starter has the engine spinning, the pattern stabilizes. The individual peaks you see are the individual cylinders. If one cylinder is low on compression, it will take less current to push that piston up and over. These peaks are all uniform, indicating even compression among all the cylinders. One note though, this is relative to all the cylinders. So if all the cylinders are low, like a timing belt that's out of time, it won't show necessarily in the pattern. Now let's look at a bad one. Can you see the difference? Notice here in the bad pattern that one of the humps is missing. 1, 2, 3, whoops. Okay, this indicates that one of the cylinders has a problem. And now we need to go a little bit further to see exactly what the problem is.
Okay, we've determined from the pattern that we do indeed have a weak cylinder. Now with a little creativity, we can trigger it off the ignition system to isolate exactly which cylinder it is by firing order. Or we can continue testing more traditionally. But in either case, I have the basic information that now I can go back to my customer and tell them with some certainty that there is a problem mechanically that we need to go into a little further and justify the additional diagnostic cost. Another tool that can be used to check the relative compression of the engine is the Cenex First Look ES100 sensor. This is a pressure transducer. It's actually a piezoelectric crystal in here that reacts to changing pressure as it's applied to the sensor, creates an electrical signal that the scope can read. This can be used in a couple of different places. It can can be used in the intake manifold vacuum, like we use the Pico transducer, or it can be used in the exhaust to check the exhaust pulses. That's how we're going to use it right now.
This is the pattern that we got after cranking the engine over. Notice the similarities to the relative compression test using starter current. All the peaks should be uniform. Can you see the one that's smaller? The one that's different? The one that indicates there's a problem? Using the Synex, we can quickly determine whether that problem is in the valve train or in the piston and rings. All we have to do is move the transducer to the oil-filled tube and measure pressure below the pistons in the same way that we measured it above. Here's a pattern showing the pulses coming from the oil-filled dipstick on car we're testing. These are all uniform, indicating that the rings are okay. The problem must be in the valve train.